the first thing that I want to say is I'm not necessarily a PHP expert, but I'm a security person that is trying to learn as much as I can about PHP for two reasons that I'm going to talk about as we go into the presentation. I did want to give just a few points about me. So this is my avatar on Twitter. This is where I live. I started my security career probably about a decade ago, and I was doing cool ass shit, doing RVAsec. But the thing is, at that time, I don't even think SQL injection was invented yet. So, but I was doing cool stuff. But for various career reasons, I went from doing that. I had to move on. I started doing some of this, which led into that, which really, led into this, which is even worse. I created tons of this, but guess what? Like all this cool stuff was going on, and I was creating this. I'm like, what the hell am I doing? So it made me want to do this. So, I thought of it. I finally, probably about a year and a half ago, now I'm in a position where I'm doing trade study type stuff. So it's really not, not super technical hands-on, but at least I'm getting to work with a lot of these security products that are out there. Still create some of this. I drink good versions of this now. I spend my own time trying to learn some of the hands-on stuff, which I try to showcase on my website, which now we actually did a name change. So I'm a little bit more happier, and I think that's it. All right, so for those that can't read that, this is first I want to give you an overview of what I will tell you over and over again during the entire presentation. So this is my version of the overview. So I'm going to first just give a little bit of history of PHP security. Then I'm going to go into detecting attacks and how at least the strategy that I've taken on my website. And then get into how to handle PHP in your environment. And the key thing there is it's in your environment. I've sort of a while ago started drinking the risk management Kool-Aid, and so the types of things or the types of controls that you implement are more based on the threats and the vulnerabilities that your particular environment has. And then we'll just close with some general thoughts. So PHP Overview. So PHP was created by Rasmus Lerdoff back in 1995. It actually it stood for Personal Homepage. Now, I don't know about you, but that doesn't sound too secure. So the background, just a little bit about PHP that they don't know, is it's a general purpose server-side scripting language, obviously used a lot, at least initially in the web development arena, to create dynamic websites. There's a lot of people that I know now that use it. They actually do a lot of their scripting and stuff just for back-end purposes too. So the language has grown some. It's interpreted, it's free, open source, so that's good. Now they came up with a better name for what PHP stands for. It's PHP Hypertext Preprocessor, and it's run by the PHP group, so it's come a long way. So the reason why I wanted to learn as much about this as I could is because I run this website, and I wanted to know and the website is based on PHP, and I wanted to know what I could do to protect the website from getting hacked. The other reason, which is on the right-hand side of the slide there, is for the past, I'd say 3-4 years, I've been going around in this security community, and we're in this echo chamber. And we're all saying, yeah, we should do these things, and it's like, yeah, right on, man. So what I wanted to do is learn something that I could then use that knowledge and reach out and can contribute back to the developers. In this case, in the PHP application development environment. So history, I mean, PHP, it started off really bad, and I think up to this point, it's fairly secure if you use it right, but there's this, but it has people still think of it in terms of its history and the problems that it's had in the past. I mean, back in the day, they had there were insecure default configurations. As an example, registered global, it wasn't disabled by default. It doesn't force type definitions, so that's nice because you don't have to like define them and what type of values are going to be in that variable. But and then on top of that, they don't necessarily have to be initialized too. So that made it easy on the programmer, but from a security perspective, it didn't too well there. And then also it has a very easy initial learning curve, and so that means anybody, some kid in high school that really doesn't have a good understanding of, say, programming theory, so they could come in and just pick up PHP and start throwing web apps out there and they're creating these things without a formal understanding of coding in a quality way, and then built on top of that, you also have the security issues. And it's also widely deployed, so obviously it's a good target. Sort of the same problem that Microsoft has had, or at least had back in the day. So the next two sections are some best practices that I came across, and these are, and I don't necessarily, I don't think they're best. I think these are things we should all be doing, and so I just call them standard practices. So the first one is this 25 PHP security best practices. In some of my initial research, I reached out to some of the Nova hackers community and several folks. We have several local hacker spaces, such as Unallocated, Nova Labs, and Reverse Space. So I reached out to them as a starting point of where I could find some good practices for what we should be doing. And so he gave this huge, so they recommended this particular article, and it's given this huge list of 25 things that you should do. And it isn't just PHP specific, but it's also it deals with the whole stack. I mean, so you're dealing with the OOS stuff, the PHP, and then the apps that run on top of that. And then even out of that, there's one of the big things now is monitoring, which is what 24 addresses. So and then as a bonus, he sort of throws in two tools. There's PHP IADS, which I have a section about that I'm going to talk about later, and there's PHP Info, which I talk about on the next slide. So I guess number 11 here is this other good Suhasin. I'm probably totally screwing up the pronunciation, but it's this advanced protection system for PHP. So what it does is it has two modules. The first one is a patch to the PHP core that stops some basic things or helps mitigate some basic things like buffer overflows and format string vulnerabilities. Then there's a second module that you would have to add on as an extension, and it has approximately 50 features, but it takes care of some of the basic things like runtime and session protection, as well as filtering and different logging features. The next thing, which is the PHP Info. So who knows what PHP Info does? Nobody? One person. All right. So what PHP Info does is you load that, it's a PHP file, and you load that up on your web server, and then you navigate to it. And then if you don't, it's good for if you're using a shared hosting provider. So what this page will display is what all your PHP configurations are. So this basically does the same thing, except instead of looking at all the different configuration parameters, it only looks at the ones that are security relevant. And it actually has built in saying, all right, as you can see there's probably about 30 things that it looks at. And so it'll go in and say, it'll give a recommendation of what that setting should be, and then it gives you, as you can see here, a green if you're doing good, or yellow warning, and they also have a red for you need to really change this. So that's a nice, good way of going in and getting a feel for, from a configuration perspective, how locked down your environment is. As for those that are familiar with doing PHP security stuff, it deals with some of the stuff, like the common things that we always hear about, such as magic quotes, registered globals, and a group and user ID. So the next standard practice that I found very useful was the OWASP PHP Top 5. And instead of just having this long list of 25 things of what the configuration should be, they actually broke it down by attack type. So you have remote code execution, cross-site scripting, SQL injection, general configuration things, and then also file system attacks. And the nice thing about this is they actually break it out into, these are, in order to stop attacks for, say, cross-site scripting, these are the things that the developer needs to do, and then they also step back and say, oh, well, for the sysadmin that's running your host, this is what they should do too. So that's a very nice reference. So the next section I wanted to, and this is about detecting attacks against your site. So there's a lot of, I could go through my web logs and look at my PHP logs and things like that, but I'm lazy, so I just wanted something that would tell me what's going on. So, and this is the definition of what by the author. So it's a security layer for your PHP-based web app. For every attack, it's given a numerical impact rating. Based on what that number is, you can program in what type of action you want it to take. So you can either say, oh, well, I just want it to log, or send an email, or do a warning message, or maybe end that process. Now, the last part is really what caught my attention, knowing that I was lazy and I didn't want to troll through my logs. So it enables you to see who's attacking your site without the tedious trawling of log files. So as soon as I saw that, I knew I was in. So just some detection mechanisms that it uses. So the first one is they have some anti-evasion normalization capabilities, and so that's all written into this converter.php file. And they also, part of it is signature based, so they in the particular file that for that is a default filter. And they also have a mathematical function, which is centrifuge. And so it does this, as it says there, it'll look at any strings that are being passed in that are greater than 25 characters. It does a ratio of the word characters over non-word characters, and then the lower that ratio is, the greater the probability of attack. Now, I don't understand all the math, and the guy that came up with this probably wrote like a thesis, so I don't understand it, but I'm just sort of going with what he has there. So the normal ratio is about 7.5, and they found that usually if it's below a 3.5, that's where you start having a higher probability of it being an attack. So with any IDS system, you install it, and you're going to get tons of false positives. This is just one example where I loaded this thing up, and I was getting just millions of attack. And it turned out it was because of there's a false positive for Google Analytics cookies. So, and as you can see there, that underscore UTMD is where you can derive that from. And so you just have to change the configuration file that I circled there. And if you look down towards the bottom, there's an exception line that you throw in. And so you just, as with any IDS system, you have to tune it and this is the way they do it there. Signature updates are pretty simple. The two files, the converter and the default filter file, you just have to go get the new ones and overwrite those. The converter file isn't updated too often, and I'd say the default filter, what they try to do is when for the signatures, they try to write them very generically so that you don't have to update them that often. But I am kind of worried because I usually don't see updates with that. It's usually between 30 to 60 days, so I do kind of worry. But and then also, whenever you want to upgrade the PHP IDS software, it's pretty easy. I'll just unzip, I'll have the PHP IDS, 0.7. So in that same directory, I'll just do the 0.8 version, and then I change the PHP IDS.php file stays the same, but I just go into that file and then just point it to the new directory. And in that way, if the thing barfs, then I can just quickly switch it back to the old version. Another nice thing you can do with it is modifying that php.ids file. So you could do sort of a thresholding where if it's between 10 and 24, it writes to a log file, 25 to 49, it logs to a database, and then the next stop would be email alert, and then a terminate page, which would just be stop the process. So there's a lot of cool things that you can do with it there. One of the things that I did want to mention on this, people have written plugins for popular content management systems. So instead of doing this manually, you can actually just get a plugin that maybe somebody wrote, and so that's a quick way to do it. And I've actually been doing that for, I'd say, about 3 months now. And I don't know, I'm a hands-on guy, and I don't trust it. I would rather see the code and control it myself, but it's something to consider. So the next thing is kind of the final part here is getting into how to handle PHP in your environment. So like I said, I'm going to talk about risk management. So my thing is that I translate risk management into, secure. The definition of secure is in the eye of the beholder. So obviously based on that, because everybody sees being secure, or everybody has a certain amount of risk that they're willing to take. So you have all your different, NIST, I'm up in DC, so we do a lot of the government-based stuff, but NIST has their risk management framework, there's FAIR, there's Octave, there's a lot of them that are out there. And the big thing here is you can look at the data or the system that you're trying to protect, and if it's not that sensitive or it's not that critical, then so you have low security. You can still secure it, but you don't have to based on the value of the data, it's worth it not spending that much money or resources trying to do that. On the other hand, if you're working directly for the government and you're doing offensive warfare stuff, maybe that's high security, so you would take a lot of, you would definitely invest more resources in protecting that sort of information. So the next few slides, there's a lot of stuff, if you go through some of those PHP best practices that I talked about, there's tons of stuff, and it's very overwhelming of what you should and what you shouldn't do. So what I try to do is go through that and maybe pull out, the top 5 things, these are hopefully the easy things that you can do. So my first recommendation for number 5 is to use some sort of a hardened environment, so that Suhasan tool that I mentioned, and you can also look at PHP Info for configuration parameters that you may want to modify. Analyze source code. So the issue here is PHP is very easy to learn. It's very easy to write. So you have a lot of people just writing code, but it's just written horribly and I mean, not only low quality, but probably also limited security built into. So I tried to go out and kind of find, and there's the big guys for doing source code stuff, which I won't mention here, but I was looking at this in terms of somebody like me that's just running a website that I don't have like this like $100,000 budget for doing IT stuff. So I was just looking for quick and cheap stuff that I could do. So one tool that a lot of people seem to like was Yaska. And that can actually do source code analysis on a number of different languages. They just have plugins for each language. The two for PHP are PHP Lin and Pixie. Now, this is free and some of it's kind of old, but it's better than, you're hoping that you can run through it and it at least at a minimum gets some of the low-hanging fruit. Now, one interesting tool that I found, which is a commercial tool, but they have a community edition, is Code Secure. And for the free version, you're limited up to 10,000 lines of code. So for someone like myself, I'm probably not going to have that many lines of code. So something like I could probably run this several times and find some of the low-hanging fruit. And because it's supported on the back end by a commercial vendor, your quality is, since it's a supported product, the quality may be higher. There's also SciHunt, Sandcat. They, once again, have a whole commercial tool, but they also have a mini analysis program that you may want to try out. So number 3 is sanitize everything in and out. So back in the day, there were, they had some methods and other sort of filtering mechanisms to protect against things like cross-site scripting and SQL injection. But there's a lot of pre-built filters that are out there so that you don't have to know how to verify an email as an email, or if you want to filter certain types of things out of code. So there's an extension called filter, and so you just do your same thing, but in the if statement, instead of putting your variable there that the user input, you just put this filter thing all around it, and then it checks it and makes sure that it tries to filter out anything malicious. So like I said too, there are also methods within PHP that have been all around. I've listed some of them there. There are also other methods which are more focused on doing system calls. I mean, you should never really have to, within your PHP code, do a system call, because that's definitely not a security best practice. However, there are some methods here that can help parse through that and hopefully filter out malicious content. So number 2 is avoid SQL concatenated strings. So, and this just gets back to SQL injection. I mean, most people, they'll actually just kind of write their SQL, they will build their SQL statement in code, and then whatever the user input, they'll just tack on to the end there, and then they'll just open a session to the database, make that call. So that's bad. I mean, I started doing RVAsec back in 2002, 2003 timeframe, and back then the big thing was use prepared database statements. That right, and almost 10 years later, we're still doing the same thing. We're building these queries dynamically and then passing them off to the database. So now PHP, as most recent version, has this PDO class. I forget what PDO stands for, but basically what it does is it allows you to do database calls in the language, and it emulates a database backend. So it kind of gets you halfway there. So you definitely, like anything that you're passing to the database, you want to use this PDO class. And if for whatever reason you absolutely can, there's this MySQL rule escape string method, which is really good, but there are some edge cases, and the recommendation from the research that I've done says, oh, you should definitely try to use this PDO class first. And then the last one, monitor. So this gets back to the PHP IDF system that I talked about a little bit earlier. The other thing is, so most of this talk really focused on looking at things from a PHP or application level, but come from the government world, so I'm a fan of defense in depth. So you definitely want to build these defense in depth protections. So at the network level, do your firewalls, your IDSs, at your platform level, harden your OSs and other apps, keep everything patched and up to date. Run AV, it'll get some of the low-hanging fruit, and obviously keep your signatures updated. At the web server level, you definitely want to harden your web server, and then there's WAFs that you can use just as an additional layer. And then testing, instead of waiting to get attacked, attack yourself. So you do periodic pen testing so that you can find those problems before the attacker does. So just to close out, I have some general thoughts here, and this is how my approach to doing RVAsec with PHP is I would go through that list of top 5, and I would do as many of those things as possible. Just do the easy stuff first that's really going to protect you. And then pick some risk assessment methodology, do a risk assessment, and then based on what your risk profile is and the amount of risk you're willing to take, implement those additional controls so that you can reduce your risk down to a tolerable level for you. And then lastly, monitor like hell. So is PHP secure? Yeah, so I gotta know, right? So I think it, like everything in security, I think it depends. And I also think we're asking the wrong question. Can anybody guess why I'm asking the wrong question?
Nothing's secure?
What?
Because nothing is secure?
Yeah, this is true. Anyone else? No brave takers? All right. So I basically think, as I mentioned, I'm drinking the risk Kool-Aid. And so I think it gets back to risk, and you have to look at is using PHP, how does that risk, or how does using PHP affect your organization from a risk perspective? And this is just my closing thought. The most secure language is the one that you know how to program securely. And that's all. Are there any questions? Nothing. Cool. So this is my contact stuff. Thank you. Thanks for having me.